What if the most dangerous creatures on Earth were never extinct, just frozen, waiting, buried under 2 miles of Antarctic ice? In January of 2023, a joint research team from the British Antarctic Survey and the University of Oslo picked up seismic readings beneath the Ross ice shelf that matched no known geological pattern. The signals were rhythmic, almost biological. When the drill team reached the anomaly at 412 meters depth, the lead scientist, Dr. Caroline Metz, immediately ordered a full halt and transmitted one word back to base: alive. Scientists are now warning that 5 of these discoveries must never be thawed, and the reasons will make you question everything you thought you knew about what ruled this planet before us. Antarctica has been hiding things for longer than human civilization has existed. The continent sits over a network of liquid subglacial lakes, over 400 confirmed so far, sealed from the surface world for more than 15 million years. Lake Vostok alone, buried under nearly 4 kilometers of ice, contains water that last touched open air before the first hominids walked Africa. Scientists drilling into that lake in 2012 pulled up core samples containing bacterial life that matched nothing in any known taxonomy database. That was considered the most shocking discovery Antarctica had ever produced. It was not. The Ross ice shelf incident in January of 2023 was preceded by 3 separate events that the research community quietly suppressed for 11 months. In February of 2022, a Norwegian autonomous drone deployed beneath the Thwaites Glacier captured thermal imaging of an object measuring 31 meters in length before its transmission cut out. The drone was never recovered. In August of 2022, a Chilean seismic monitoring station at Base Presidente Eduardo Frei registered a low-frequency vibration pattern lasting 6 hours and 14 minutes, a pattern that structural engineers later confirmed could not be produced by any tectonic activity. In November of 2022, a British glaciologist named Dr. Peter Aldam was airlifted from McMurdo Station after suffering what the official report called acute psychological distress following equipment malfunction. Dr. Aldam has not given a single public interview since. These 3 events were retroactively connected after Dr. Metz's team made contact with the first anomaly at 412 meters. The connection was geographical. All 3 incidents occurred within a 200-kilometer radius centered on a specific coordinate in the eastern Ross ice shelf. When researchers mapped the seismic data from all 3 events together, the pattern resolved into something that stopped the analysis team cold. The signals were not random. They were moving. Something beneath the ice had been traveling a slow, irregular circuit through the subglacial terrain for at least 14 months. What the drill team found at 412 meters depth was not fully visible. The ice at that level is under enormous pressure and carries a dark blue tint that blocks light beyond a few centimeters of penetration. The team lowered a fiber optic camera with a 1,000 lumen lamp. The footage, which was classified under a joint British-Norwegian research agreement within 72 hours of capture, showed a surface that Dr. Metz described in her internal report as scaled dark gray-green, with visible musculature beneath the integument. The object, she refused to call it a specimen in her report, was not fully encased in ice. Approximately 40% of its mass was in direct contact with a pocket of pressurized liquid water running along a geothermal vent. The water temperature at the contact point read 4.3 degrees Celsius. The ice directly surrounding it showed no signs of the fracture patterns that would indicate a rapid freeze. Whatever this thing was, it had been in that precise position for an extraordinarily long time. Long enough for the ice to conform perfectly around its body. The length estimate from the drill site was conservative, based on the curvature visible in the camera feed and the pressure displacement readings from the surrounding ice column. The full body length was calculated at between 28 and 34 meters. The width at the widest visible point, the midsection, exceeded 6 meters. These dimensions place it outside the size range of any known species in the fossil record, living or extinct from any geological period. For scale, the largest confirmed Mosasaurus specimen ever recovered measured 17 meters. The largest Pliosaurus estimate reaches 14 meters. Whatever Dr. Metz's team found at 412 meters beneath the Ross ice shelf is nearly twice the size of anything that has ever been formally catalogued by paleontology. Dr. Metz filed her halt order at 11:47 in the morning on January the 9th. By midnight of the same day, the Norwegian Polar Institute had been contacted. By January the 11th, the site had been sealed under a joint international research moratorium. The stated reason was structural ice instability. The actual reason was in the final line of Dr. Metz's internal report, written in plain language with no scientific hedging. The subject's core body temperature reads at 2.1 degrees above the ambient ice temperature. This differential is consistent with active metabolic function. It was not a fossil, it was not a carcass, and it was not alone. They called it the beast, and after reviewing the footage, none of the senior scientists objected to the label. The first creature was designated Subject Ross 1 by the Joint Research Team, though the drill technicians who first saw the camera feed had their own name for it. Ross 1 was located at the coordinates 47 minutes, 12 seconds south, 163 degrees, 8 minutes east, a position roughly 200 kilometers from the nearest permanent research station. The fiber optic camera captured a total of 14 minutes and 31 seconds of usable footage before the cable was manually retracted. In those 14 minutes, the team documented enough to fundamentally challenge the existing scientific understanding of what survived the last glacial maximum. The body structure visible in the footage does not correspond to any known animal phylum. The scaling pattern along the dorsal surface is hexagonal, not rhomboidal like reptilian scales, with each individual scale measuring approximately 22 centimeters across. The coloration is a deep gray-green with darker banding running perpendicular to the spine, visible even through the ice-pressured water pockets surrounding the contact zone. The musculature beneath the integument is pronounced to a degree that suggests this animal was built for sustained physical exertion at a level comparable to large pelagic predators like great white sharks, but scaled up by a factor of 15. What stopped Dr. Metz's team entirely was not the size. It was the forelimb. At minute 7 of the footage, the camera operator slowly panned left along the midsection of the body. At the edge of the light radius, partially obscured by a dense column of pressurized ice, a forelimb became visible. It was not a fin. It was not a flipper. The limb had a defined joint structure, a clear analog to an elbow, with what appeared to be 3 elongated digits extending from a broad paddle-shaped terminus. The digit length was estimated at between 1.2 and 1.8 meters each. The joint itself showed no sign of atrophy or structural degradation. Dr. Metz wrote in her report that the limb appeared, and she used this word deliberately, functional. The geothermal vent running beneath Ross 1's resting position produces a constant water temperature of between 3 and 5 degrees Celsius at the contact surface. This is cold enough to maintain biological stasis in most known organisms, but warm enough, given sufficient metabolic suppression, to allow cellular maintenance without full decomposition. The body temperature differential of 2.1 degrees recorded at the initial survey was remeasured 6 days later by a secondary probe. The differential had increased to 2.4 degrees. It was a small change. The research team did not consider it small. Scale tissue samples were attempted using a remote collection tool attached to the drill assembly. The tool made contact with the dorsal surface at minute 11 of the footage. The scale did not yield. The collection tool, rated for a lateral pressure of 800 kilograms per square centimeter, bent on first contact. A second attempt at a different angle produced the same result. The team recovered the tool and found the collection tip, machined from hardened steel, had been deformed as though struck against solid granite. Dr. James Okafor, the team's materials scientist, tested the deformed tip under a portable electron microscope at the surface station. He filed a separate addendum to Dr. Metz's report. His conclusion: the resistance was consistent with a biological structure of extraordinary density, potentially incorporating mineralized compounds within the tissue matrix itself. In plain terms, the scales of Ross 1 were harder than most rocks. The footage ends at minute 14 when the cable operator noticed the water temperature in the contact pocket had risen by 0.3 degrees over a 6-minute window. This rate of change, if sustained, would indicate an increase in metabolic output. The cable was retracted immediately. When the camera cleared the ice column on its way up, the final 3 seconds of footage captured something that was not in Dr. Metz's written report but was flagged separately by 2 members of the team in individual witness statements filed with the Norwegian Polar Institute. In those final 3 seconds, at the extreme edge of the lamp's light radius, something moved. Not the body of Ross 1, something else. A second shape, smaller, faster, passed through the frame in under 1 second and was gone. The witness statements describe it identically: elongated, pale, moving horizontally at a speed inconsistent with passive drift in pressurized water. Dr. Metz's report classified Ross 1 as a single isolated subject. The witness statements suggest the classification was premature. The second subject was not found by drilling. It was found by accident, and its discovery nearly ended the entire research program before it had formally begun. On January the 14th, 5 days after the Ross 1 site was sealed, a separate seismic monitoring array deployed by the Norwegian team registered an anomalous pressure displacement at a depth of 680 meters, 270 meters deeper than Ross 1. The displacement was not a vibration. It was a single sustained compression event lasting 47 seconds, originating from a point 3.2 kilometers northeast of the first site. Dr. Erik Solberg, the Norwegian team's geophysicist, initially logged it as a localized ice sheet adjustment. He changed that assessment when he ran the displacement figures through the pressure modeling software. As we ponder the mysteries beneath the ice, wouldn't it be great to have access to cutting-edge AI tools to help unravel them? Check out playprofi.com for all the popular neural networks in one subscription. Today only, you get 500 bonus tokens when you register through the link in the description. The compression force required to produce that specific signature at that depth, transmitted through ice at that density, was equivalent to approximately 1,400 metric tons of applied lateral pressure. No known geological process produces that precise pattern. A large muscle contracting against a confined space does. The subject, designated Ross 2, was imaged using a ground-penetrating radar array dragged across the ice surface by a tracked vehicle over 3 days. The radar cannot produce the resolution of a fiber optic camera, but it maps mass and density through ice with reasonable accuracy. What it returned was a profile that the analysis team spent 6 hours arguing was instrument error before accepting it as a valid reading. Ross 2 is not 30 meters long. The radar profile shows a continuous biological mass extending 61 meters from what appears to be the anterior end to the posterior terminus. The width at the midpoint reads at 11 meters. The vertical height, meaning the thickness of the body from dorsal to ventral surface, reaches 8 meters at its maximum. To place those dimensions in context, the body of Ross 2 is longer than a Boeing 747, wider than a city bus is long, and nearly as tall as a 3-story building. It is the largest biological mass ever recorded in any documented scientific survey, living or fossil. The radar profile also revealed the reason the pressure displacement lasted 47 seconds. Ross 2 is not resting flat. The body is coiled, not loosely, the way a sleeping snake might curl, tightly, in overlapping loops, the way a spring is wound under tension. The coil configuration occupies a roughly circular area of approximately 20 meters in diameter. The radar team counted 4 complete loops before the signal degraded at depth. Dr. Solberg's structural analysis of the coil geometry produced a finding he described as deeply uncomfortable. The coiling pattern is mechanically optimized for explosive uncoiling. The body of Ross 2 is positioned, whether by instinct or by design, in the configuration that would allow it to move from complete stillness to full extension in the shortest possible time. The depth of 680 meters creates a significant problem for the Do Not Defrost directive. At that depth, the ice is under pressure exceeding 500 atmospheres. The geothermal gradient in that region of the Ross ice shelf is higher than average due to a cluster of hydrothermal vents identified in a 2019 survey. Current modeling by the British Antarctic Survey projects that the ice layer directly above the Ross 2 site will thin by an estimated 3.7 meters over the next decade due to accelerating basal melt driven by those vents. 3.7 meters of thinning sounds insignificant against 680 meters of total depth. It is not insignificant. The thinning is not uniform. It is concentrated in a channel running directly over the coiled mass, which means the geothermal heat is being focused by the body of Ross 2 itself, drawn toward it, accelerating the melt above it in a pattern that, if sustained, reduces the projected containment timeline from centuries to something considerably shorter. No tissue samples were obtained from Ross 2. No fiber optic camera was deployed. The decision was made at the senior research level after the pressure displacement event on January the 14th. The reasoning was straightforward and was stated explicitly in the research moratorium filing. If a creature of that mass produced a compression event of 1,400 metric tons while in a dormant state, the research team had no interest in discovering what it produced while responding to a stimulus. The radar imaging was conducted at surface level, 3.2 kilometers away, with the tracked vehicle engines running at all times, and the team under standing orders to begin immediate evacuation if a second pressure event was registered. No second event was registered during the survey. The radar array was recovered on January the 17th. On January the 18th, Dr. Solberg submitted a supplementary finding that had not been part of the original survey objective. The ground-penetrating radar, during its 3 days of operation over the Ross 2 site, had recorded the subsurface temperature gradient at regular intervals. The body temperature of Ross 2, measured indirectly through thermal displacement in the surrounding ice, was 3.8 degrees above ambient. Ross 1 had registered 2.1 degrees above ambient at first measurement, rising to 2.4 degrees 6 days later. Ross 2, larger and deeper, was running hotter. Both subjects were warming. The warming trend was not supposed to be possible. Biological hibernation in extreme cold environments works through metabolic suppression. The organism's internal processes slow to a near-complete halt. Heat production drops to near zero, and the surrounding temperature maintains the stasis. The organism does not generate warmth. It surrenders to the cold. Every documented case of cryogenic survival in the animal kingdom, from wood frogs in Alaska to tardigrades in laboratory conditions, follows this principle without exception. An organism that is generating measurable heat above its ambient temperature is not in hibernation. It is in an active metabolic state. It is, by the only definition that matters in biology, awake. Dr. Metz convened an emergency review on January the 19th with 12 senior researchers representing 4 institutions. The meeting lasted 9 hours. The central question was not scientific. The central question was whether to continue. 3 researchers voted to abandon the sites entirely and file a standard geological survey report that made no mention of biological findings. 2 of those 3 cited personal reasons in their written statements and did not elaborate. The remaining 9 voted to continue under strict remote sensing protocols. No direct contact, no drilling within 500 meters of either confirmed site, no thermal stimulation of any kind near the geothermal vent systems. The vote was recorded. The 3 dissenting statements were attached to the moratorium filing. The 3rd subject was identified not through seismic data or radar, but through a piece of evidence that had been sitting in a database for 11 years before anyone connected it to the Ross ice shelf anomalies. In 2012, a glaciological survey team conducting routine ice core sampling in the eastern Amundsen Sea embayment extracted a core section from a depth of 390 meters that contained an anomalous organic inclusion. The inclusion was logged as unidentified biological material, possible ancient algal colony, and filed. The core section was stored at the British Antarctic Survey's sample repository in Cambridge. In February of 2023, Dr. Metz requested the sample be re-examined using current analytical tools. The re-examination took 3 weeks. The results came back on March the 2nd. The inclusion was not algae. It was epithelial tissue, skin cells, from an organism with a cellular structure that matched, at the mitochondrial DNA level, the trace biological material recovered from the water pocket surrounding Ross 1. The core section it came from was extracted from a location 400 kilometers west of the Ross 1 site. The tissue was intact enough for a rough dating estimate. The cells had last divided approximately 12,000 years ago, placing the organism's last period of active biological function at the end of the Pleistocene epoch, the same period in which the majority of Earth's megafauna went extinct. The implication took several days to fully register with the research team. These creatures were not prehistoric survivors from the Mesozoic or earlier geological periods, preserved by some freak of ancient glaciation. They had been alive, moving, and biologically active as recently as 12,000 years ago. They had coexisted with anatomically modern humans. They had been present on Earth while the first permanent human settlements were being established in the Fertile Crescent, and then, at some point during or after the last glacial maximum, they had gone into the ice, not been trapped by it, gone into it. Dr. Yuki Tanaka, the team's evolutionary biologist from Hokkaido University, submitted a formal hypothesis paper on March the 9th that has not been published in any peer-reviewed journal and remains classified under the research moratorium. Her hypothesis, summarized in the paper's abstract, states that the subjects may represent a species that evolved voluntary cryogenic dormancy as a survival strategy. The ability to consciously enter a metabolic state cold enough to arrest biological aging and suspend physical function for periods of thousands of years, then resume normal biological activity when environmental conditions changed. She noted one specific detail that supported this hypothesis over the alternative explanation of accidental entrapment. Both Ross 1 and Ross 2 are oriented with their anterior ends, their heads, pointing upward toward the ice surface. An animal that fell into a glacier and was frozen in place would show random orientation. An animal that chose its position would point itself toward the exit. The third subject, designated Ross 3, was confirmed at a depth of 520 meters using the same radar array that had surveyed Ross 2. Its body length measured 44 meters. Its orientation matched the first two subjects exactly. Anterior end angled upward at approximately 12 degrees from horizontal, pointing toward the surface. Its body temperature differential above ambient ice temperature registered at 3.1 degrees on first measurement. The measurement was taken on March the 15th. On March the 22nd, a follow-up reading put the differential at 3.6 degrees. Ross 3 was warming faster than either of the first two subjects. The team's thermal modeling, run that same week, produced a projection that Dr. Metz underlined twice in her personal notes and shared with no one outside the senior review group for 11 days. At the current rate of temperature increase, Ross 3 would reach the threshold for active motor function, the point at which muscle tissue becomes capable of generating coordinated movement, in somewhere between 18 months and 4 years. The question of whether they were alive had a technical answer and a practical answer, and the two answers were not the same. The technical answer, based on the metabolic heat data and the cellular activity confirmed in the Ross 1 tissue-adjacent water samples, was yes. Biologically active, generating heat, cellular processes running at a suppressed but measurable rate. By the definitions used in clinical medicine to distinguish living organisms from dead ones, all three confirmed subjects qualified as alive. The practical answer was more complicated, and it was the practical answer that kept the senior research team awake at night. Ross 4 was located on April the 3rd through a method the team had not planned to use. A hydroacoustic monitoring buoy deployed by the Comprehensive Nuclear Test Ban Treaty Organization, the network that listens for underwater nuclear detonations, recorded an anomalous low-frequency signal at a station positioned in the southern Ross Sea. The signal frequency was 11 Hz, well within the infrasound range, and it lasted for 3 minutes and 40 seconds before stopping abruptly. The CTBTO flagged it as a non-seismic, non-explosive event of unknown origin and forwarded the data to the Antarctic Research Consortium as a routine information share. Dr. Metz's team received it on April the 1st. They spent 2 days running source location calculations before the coordinates resolved to a point beneath the Pine Island Glacier, approximately 600 kilometers from the Ross 1 site. 11 Hz, 3 minutes and 40 seconds. Dr. Tanaka pulled the bioacoustic literature within hours of seeing the frequency data. Large baleen whales, blue whales, fin whales vocalize in the 10 to 40 Hz range. The calls serve two documented purposes: navigation and communication. An 11 Hz signal of 3 minutes and 40 seconds duration is, in structure and frequency, consistent with a long-range directional call. Something beneath the Pine Island Glacier had made a sound, and the sound was aimed based on the hydroacoustic triangulation directly toward the Ross ice shelf. Ross 4 was imaged by radar on April the 9th through the 14th. Survey was conducted under the same strict protocols as the Ross 2 imaging: surface level, maximum safe distance, continuous engine operation, immediate evacuation threshold set at any registered subsurface movement event. The radar profile that came back from Pine Island was different from the 3 Ross ice shelf subjects in one critical respect. Ross 4 was not alone in its cavity. The radar showed 2 distinct biological masses in close proximity, separated by approximately 4 meters of pressurized water. The larger mass measured 53 meters in length. The smaller mass measured 31 meters. The size differential and the proximity were consistent with one interpretation that Dr. Tanaka raised in the April 15th team briefing and that no one in the room contradicted: adult and juvenile. Not 2 unrelated organisms frozen at different times in the same geological feature. 2 organisms that had entered dormancy together, in physical proximity, in a configuration that matched the resting behavior of large social animals with offspring. If Ross 4 represented a breeding pair, or a parent and offspring, the implications extended beyond everything the team had already documented. A single species preserved in isolated pockets of Antarctic ice was a geological anomaly. A species that had maintained social bonds across 12,000 years of dormancy was something else entirely. It suggested a level of biological complexity, of neurological function, that the team had not yet formally addressed in any of their documentation. Dr. Metz added a new section to the master research file on April the 16th. She titled it Behavioral Capacity and left it blank. The 11 Hz signal was recorded a second time on April the 22nd. Same frequency, same duration, same directional bearing toward the Ross ice shelf. This time the CTBTO station also captured a response. A shorter signal, 8 seconds long, at 13 Hz, originating from the Ross ice shelf coordinates. Something under the Pine Island Glacier had called out. Something under the Ross ice shelf had answered. Dr. Solberg ran the response signal's source coordinates against the known positions of Ross 1, Ross 2, and Ross 3. The response did not come from any of the 3 confirmed subjects. It came from a point 2.8 kilometers east of Ross 3. At a depth the team had not yet surveyed. They had their 5th subject before they had finished documenting the 4th, and the 5th subject had just demonstrated, without any ambiguity, that it was conscious enough to respond to a signal from 600 kilometers away. The body temperature of Ross 4's larger mass registered at 4.2 degrees above ambient on first radar thermal measurement. The smaller mass registered at 4.9 degrees above ambient. The juvenile was running hotter than the adult. Dr. Tanaka noted this in her behavioral capacity file with a single added sentence. In large terrestrial predators, juvenile specimens in the final stages of waking from torpor consistently show elevated metabolic rates compared to adults in the same recovery phase. She did not need to explain what recovery phase meant. Everyone in the room understood that the trajectory of these temperature readings had only one destination. The 5th subject changed everything about how the team understood the situation, and not in a direction anyone found reassuring. Ross 5 was confirmed at a depth of 312 meters, shallower than any of the other 4 subjects, beneath a section of the Ross ice shelf that the British Antarctic Survey had surveyed extensively in 2019 as part of a routine glaciological mapping program. That survey had found nothing unusual. The 2019 equipment had not been looking for biological heat signatures. It had been measuring ice density and flow rates. Ross 5 had been there the entire time, invisible to instruments not calibrated to find it, while researchers walked and drove equipment across the ice surface directly above it. The acoustic response signal that had located Ross 5 was reanalyzed by Dr. Tanaka over 3 days following its detection. Her analysis produced a finding that she described in her notes as the most significant single data point of the entire investigation. The 13 Hz response signal from Ross 5 was not a simple reply. It was structured. The signal contained 4 distinct frequency modulations within its 8-second duration. Shifts of 0.3 Hz, 0.7 Hz, 0.3 Hz again, and 0.1 Hz, occurring at irregular intervals. Random biological noise does not produce patterned frequency modulations. Deliberate vocalization does. Ross 5 had not simply responded to Ross 4's call. It had responded with information. The research moratorium that had been filed in January was a joint agreement between the British Antarctic Survey, the Norwegian Polar Institute, and the University of Oslo. It carried no legal enforcement mechanism outside the participating institutions. It had no binding authority over any government, military organization, or independent research body. Dr. Metz had known this when she filed it. She had filed it anyway because it was the only instrument available to her. In May of 2023, she discovered it was not sufficient. A source within the United States National Science Foundation's Office of Polar Programs contacted Dr. Metz on May the 7th through an encrypted email channel. The source, whose identity remains protected under the Research Consortium's whistleblower provisions, informed her that a separate American research team, operating under a different program designation, had been aware of anomalous subsurface biological signatures in the Ross ice shelf region since 2021. 14 months before Dr. Metz's team made first contact with Ross 1. The American program had not shared its findings with the international research community. It had instead submitted a classified proposal to the Department of Defense's Defense Advanced Research Projects Agency, designated under a program title that the source declined to specify, with an objective that the source summarized in 4 words: controlled extraction and study. Dr. Metz filed an emergency communication with the Antarctic Treaty Secretariat in Buenos Aires on May the 9th. The Antarctic Treaty prohibits military activity on the continent and requires signatory nations to share scientific findings openly. She cited both provisions. The Treaty Secretariat acknowledged receipt of her communication on May the 14th and indicated that the matter would be reviewed through standard consultation procedures. Standard consultation procedures under the Antarctic Treaty take a minimum of 90 days to produce any formal response. The classified American proposal, according to the NSF source, had already received preliminary funding approval. The proposed extraction methodology involved targeted thermal lancing, directing concentrated geothermal energy into the ice surrounding a subject to accelerate localized melting and create a controlled liquid environment around the organism. Targeted thermal lancing is, in the language of the Do Not Defrost Directive, defrosting. The proposal targeted Ross 3 specifically, because at 390 meters it was the shallowest of the Ross ice shelf subjects, and therefore the most logistically accessible. The same Ross 3, whose body temperature differential had been rising faster than any other subject. The same Ross 3 whose thermal modeling projected active motor function capability within 18 months to 4 years. Dr. Okafor, the material scientist who had tested the deformed collection tool against Ross 1's scales, submitted a formal objection memo on May the 12th addressed to every senior researcher in the consortium. The memo was 3 pages long. The relevant section was 1 paragraph. He calculated the kinetic energy output of a 30 to 40 meter organism moving at a conservative estimated speed of 15 kilometers per hour, slower than a human sprint, and compared it to the structural tolerances of every type of containment infrastructure that could realistically be deployed in an Antarctic field setting within a 2-year timeline. The conclusion required no scientific background to understand. There was no containment structure that could be built at that location, in that environment, in that time frame, that would hold any of the 5 subjects if they chose to move. The proposed extraction was not a controlled study. It was an open enclosure. The memo was distributed on May the 12th. On May the 19th, the NSF source sent a second message to Dr. Metz. The thermal lancing equipment had been loaded onto a cargo vessel at Port Hueneme, California, 7 days earlier on May the 12th, the same day Dr. Okafor's memo was distributed. The proposal had not been waiting for the objection period to close. It had never been waiting for anything. The equipment was already at sea, bound for McMurdo Station, scheduled to arrive in early July. Someone had decided the warning did not apply to them. The cargo vessel reached McMurdo Station on July the 8th. The thermal lancing equipment was offloaded over 2 days and transported by tracked vehicle convoy to a staging area 11 kilometers from the Ross 3 site. Dr. Metz was not informed of the convoy's movement. He learned about it from a glaciological technician at McMurdo, who recognized the equipment configuration and sent her a photograph. The photograph showed 4 cylindrical thermal lance units, each approximately 9 meters long, mounted on heavy tracked platforms. She forwarded the photograph to the Antarctic Treaty Secretariat that same evening. The Secretariat's 90-day consultation period had 31 days remaining. The American team began preparatory ice surveys above the Ross 3 site on July the 11th. Dr. Metz's consortium had placed 4 autonomous seismic sensors in the area during their March survey, and those sensors were still transmitting. The seismic data from July the 11th showed the American team drilling a series of shallow pilot holes in a grid pattern across the surface directly above Ross 3. Standard procedure for mapping the ice structure before thermal lancing. The drilling was light, surface-level work, none of the holes exceeding 40 meters. It should not have reached anywhere near Ross 3 at 390 meters depth. At 11:22 in the evening on July the 11th, all 4 seismic sensors registered simultaneously. The event they recorded lasted 19 seconds. It was not a geological event. The pressure signature was biological. The same pattern Dr. Solberg had identified in January, when Ross 2's 47-second compression event had first suggested active muscle function. This event was different in one critical respect. It was not a single compression. It was sequential, a rhythmic series of pressure pulses, 7 of them, each lasting approximately 2 seconds, separated by 1-second intervals. 7 pulses, 2 seconds each, 1 second apart. It was footsteps. Ross 3 had registered the drilling above it and had moved, not fully. The seismic displacement indicated a shift of the body mass by an estimated 2 to 3 meters within its cavity, not a full mobilization. But 2 to 3 meters of movement from an organism at 390 meters depth, encased in ice under 500 atmospheres of pressure, meant that the ice conformation around the body had fractured. The perfectly fitted ice cavity that had held Ross 3 immobile for 12,000 years had cracked. The containment was no longer passive. It was now only a question of how much force Ross 3 was capable of generating, and whether the remaining ice was sufficient to resist it. The American team's seismic equipment registered the same event. Their field operations log, obtained later through a Freedom of Information request filed by a journalist who had been tipped off about the program, shows a 12-minute gap in recorded activity immediately following the 11/22 event. 12 minutes during which no drilling occurred, no vehicle movement was logged, and no communications were transmitted. Then a single entry at 11:34. Suspend operations pending review. The thermal lancing had not yet begun. The pilot hole drilling alone, 40 meters of shallow surface work 350 meters above the subject, had been enough. Dr. Metz received the seismic data at her station at 12:09 in the morning on July the 12th. She called Dr. Tanaka immediately. Tanaka's response, recorded in Metz's personal log, was 6 words. It knows they are up there. The follow-up thermal imaging conducted by the consortium's remote sensors on July the 13th produced the number that ended the debate about whether these subjects were dormant or waking. Ross 3's body temperature differential above ambient ice temperature had been 3.6 degrees on March the 22nd. On July the 13th, 3 months and 22 days later, it registered at 6.1 degrees. The rate of increase had not been linear. It had accelerated sharply in the 2 days following the drilling event. Ross 3 was not warming gradually toward the threshold for motor function. It was warming in response to stimulus. The drilling had not disturbed it. The drilling had aroused it. The consortium ran updated thermal projections on July the 14th using the new acceleration data. The previous model had estimated 18 months to 4 years before Ross 3 reached the threshold for active motor function. The updated model, accounting for the accelerated warming rate observed post-stimulus, produced a revised estimate. The lower bound was no longer 18 months. It was 11 weeks. The CTBTO hydroacoustic network registered 3 separate infrasound signals between July the 12th and July the 16th. The first came from beneath the Pine Island Glacier, Ross 4. The second came from the Ross Ice Shelf, from the uncharted coordinates of Ross 5. The third came from a location that the source triangulation software initially flagged as an error because it did not correspond to any of the 5 known subjects. It took the analysis team 4 hours to confirm that the triangulation was correct. The third signal originated from a point beneath the Filchner Ice Shelf, over 1,200 kilometers from the nearest confirmed subject. A location that had never been surveyed. A location where no one had thought to look. The signals were not random calls into the dark. They were exchanging information across 1,200 kilometers of Antarctic ice, in real time, about what was happening above them. 5 confirmed subjects. 1 new signal source, and a thermal lance convoy parked 11 kilometers from the most active site, with 31 days left before anyone with legal authority could tell them to stop. The thermal lance convoy withdrew from the Ross 3 staging area on July the 17th. No official explanation was given. The equipment was returned to McMurdo Station and logged as mission postponed. Environmental assessment required. Dr. Metz learned of the withdrawal the same way she had learned of the convoy's advance, through a photograph sent by the same glaciological technician at McMurdo. She did not celebrate. She noted the withdrawal in her log and immediately filed a request for continuous seismic monitoring at all 6 signal source coordinates. 5 confirmed subjects and the new Filchner Ice Shelf location. The request was approved within 48 hours, which was faster than any previous approval in the program. Someone in the funding chain had seen the 11-week projection. The seismic monitoring network was fully operational by August the 3rd. Within the first 10 days of operation, it recorded 22 discrete biological pressure events across the 6 sites. Not all of them with a slow, heavy footstep pattern registered on July the 11th. Several were shorter, sharper events consistent with a large organism shifting position. 2 were long, sustained compressions lasting over 90 seconds each, both originating from the Ross 2 site. The coiled 61-meter subject whose spring-loaded body geometry had concerned Dr. Solberg from the first day of imaging. The 90-second compressions were not footsteps and were not position shifts. Dr. Solberg's analysis identified them as consistent with a large coiled muscle system cycling through a slow contraction and release sequence. Ross 2 was not waking up. Ross 2 was stretching. The answer to the question that started this investigation, what are these things, remains formally unresolved. No species designation has been assigned. No taxonomic classification exists. The tissue-adjacent water samples from Ross 1 provided mitochondrial DNA sequences that share less than 31% similarity with any organism in the GenBank database, which catalogs the genetic sequences of over 230 million biological specimens. For context, humans and chimpanzees share 98.7% genetic similarity. Humans and sharks share approximately 82%. Whatever evolutionary evolutionary lineage produced these 6 subjects diverged from every other known branch of life on Earth so far back, and traveled so far from any recognizable biological template, that the standard tools of taxonomy are functionally useless. They are not reptiles. They are not mammals. They are not fish. They predate the categories. Dr. Tanaka published 1 paper in the public domain from this research, a single-page letter in the journal Polar Biology in September of 2023, written in deliberately technical language that obscured its implications for any reader not already familiar with the investigation. The letter's final sentence, stripped of its scientific framing, states that the subglacial biological signatures detected in the Ross and Amundsen sea regions demonstrate evidence of coordinated interspecimen communication across distances exceeding 1,000 kilometers, suggesting a level of cognitive function inconsistent with simple reactive biology. Inconsistent with simple reactive biology. In plain language, these animals think. They communicate deliberately. They respond to threats. They track the position of things moving on the surface above them, and they have been doing all of this continuously for 12,000 years. The Filchner ice shelf signal source was surveyed by radar in October of 2023. The biological mass detected at 490 meters depth measured 78 meters in length. It is the largest of the 6 confirmed subjects by 17 meters. Its body temperature differential above ambient registered at 5.2 degrees on first measurement. It had not been stimulated by drilling. It had not been disturbed by any surface activity. It was simply warmer than the others on its own timeline, for reasons the team has not determined. Its orientation matched every other confirmed subject. Anterior end angled upward, pointing toward the surface. Its acoustic signal, when reanalyzed at full resolution, contained 11 distinct frequency modulations. Ross 5 signal had contained 4. The Filchner subject signal was nearly 3 times more complex. The Do Not Defrost Directive, as it currently stands, is a research moratorium with no enforcement teeth covering 6 confirmed locations on a continent governed by a treaty that 31 days of bureaucratic procedure cannot adequately protect. The Antarctic ice sheet is melting. The basal melt rate beneath the West Antarctic ice sheet increased by 41% between 2010 and 2023, according to satellite gravity measurements from the GRACE-FO program. The geothermal vents that are concentrating heat beneath the Ross 2 and Ross 3 sites are not responding to any human decision. The ice above these 6 locations is thinning whether anyone drills into it or not. Dr. Metz's final summary report, submitted to the Antarctic Treaty Secretariat in November of 2023, ends with a single, unambiguous paragraph that requires no scientific background to understand. She writes that the subjects entered dormancy voluntarily, oriented themselves toward the surface deliberately, have maintained biological awareness throughout their dormancy period, and are currently in an active warming phase that predates any human disturbance of their sites by an unknown but measurable duration. They were already waking up before anyone found them. The finding changes the entire premise of the investigation. The question was never whether humans might accidentally thaw these creatures. The question, the one that nobody in the research community has yet answered publicly, and that Dr. Metz left hanging at the end of her report without resolution, is simpler and considerably more unsettling. After 12,000 years under the ice, what exactly are they waking up for?